All right, here we are for activity number 3, switching among forms. So here we're going to be looking at going between standard form and general form for circles and ellipses. Recall activities 1 and 2, you learn the standard forms for equation of a circle and ellipse. So that standard form, we can quickly pick out the center of the circle and we can find the radius. And then for the ellipse, we can again quickly find the center of the ellipse and then the horizontal radius and the vertical radius. So notice what those standard form looks like. And then we're going to try to go to general form. We've actually done some of that already. It's really just multiplying these out and then get all the variables on one side of the equation and all the constants on the other. And this would obviously simplify down to one single number. And then for ellipse, same thing, multiply them out. We don't want any fractions, so we'll figure out how we're going to deal with that. And then we put all of the constants on one side and all of our variables on the other. So let's get into it. Converting from standard form to general form, identify what we want for the circle and the ellipse, the center, the radius, and then we're going to rewrite that in general form. So for question 1A, we see that this is a circle, matches up with our standard form up here. The radius is the square root of 49, so it's 7, and that's both horizontal and vertical. The center is going to be +3, +5, so 3, 5. And then 4 key points, we can go 7 units, right, left, up, and down. And those would be 4 points that are on the circle. And then when we put it in the general form, we need to multiply this out. So we're going to get really good at multiplying these. Binomial squared. So we get x squared minus 6x plus 9, and y squared minus 10y plus 25 equals 49. And then we'll subtract 9 and subtract 25 from the 49, so this now becomes a 15. Typically, we put the higher degree terms first, so x squared and then y squared, and then minus 6x and minus 10y. So here is our general form for this particular circle. Now, if you notice, we're going to have to at some point work backwards, go this way. So we're going to do what's called complete the square as we get into this. So we're going to get this trinomial and this trinomial, and then we're going to rewrite them like we have up here. So a little foreshadowing there. All right, part B, this is going to be an ellipse now because I'm dividing by different numbers down here. So I have different radius for the horizontal and for the vertical. The center is going to be at 2, -4. So I grab those off of the x and y part. The horizontal radius is the square root of 9, so that's 3. Vertical radius is the square root of 4, so that's 2. So from the center, I'm going to go up and down 2. And for the horizontal radius, I'm going to go left and right 3. So left and right 3, I keep the -4, 2 goes to 5, 2 goes to -1. And then from 2, -4, -4 goes to -2, and -4 goes to -6. Here we're going to multiply this out. So here the first thing I want to do is get rid of the fractions. So in order to do that, what I want to do is multiply by something that both 9 and 4 go into. So I'm going to multiply everything by 36. And then what we notice is 36 divided by 9 ends up being a 4. So I have 4 times x minus 2 quantity squared. 36 divided by 4 is 9. So I have 9 times y plus 4 squared. And then 1 times 36 is 36. So now I got rid of the fractions. A common mistake or misunderstanding is that you can just put that 4 in front of this and that 9 in front of the other one. It works out that way on this one and some other ones that we're going to see. But that's not always going to necessarily be the case, depending on what number we're multiplying by. So expand out this binomial squared, expand out this binomial squared, distribute the 4, distribute the 9. And now I have to subtract 16 and subtract 144 from 36. So I get -124 on the right side. A little bit of reorganizing, x squareds, y squareds, x's and y's, and then we're good to go. So there is the general form for the ellipse. Notice these two numbers are different. 4x squared, 9y squared. Here we had a 1x squared, 1y squared. That's going to be a difference that we see when we get into deciding, is it a circle or is it an ellipse? Number 2, let's consider this equation. 4 times x minus 3 squared plus 9 times y minus 5 squared equals 36. How can I tell that it's an ellipse and not a circle? That leading coefficient number. Those are different in each of those particular terms. So 4 times and 9 times, I know that that's going to be different. Rewrite it. So how do I rewrite this? I want this to be a 1 over here for an ellipse. So what I have to do is I'm going to divide everything by 36. So as I divide by 36, and then we get some simplifying. 4 goes into 36 9 times, so I get a 9. 9 goes into 36 4 times, so I get a 4. 36 divided by 36, I get that 1 that I wanted over here. Now I can find out some of the parts. The center is going to be at 3, 5. Horizontal radius is going to be the square root of 9, 3. Vertical radius is the square root of 4, 2. From the center, I'll go right and left 3, so 0, 5, 6, 5. And I can go up and down 2, so 3, 7, 3, 3. Rewrite that in its equivalent general form. So I would probably go back up to the one that they started with for us and go ahead and expand out. X minus 3 squared, y minus 5 squared, distribute the 4, distribute the 9, minus 36 from both sides, minus 225 from both sides, and I end up with negative 225 on the right side. Rearrange over here, 4x squared plus 9y squared minus 24x minus 90y. So that particular process really should be just some advanced algebra review, because it's multiplying and distributing and putting things on the same side of the equation. Where we get into this, going into standard form, that's a little bit more difficult because we have to get this completing the square process done. So here we have the steps. We're going to complete the square. We have to make sure that we add things to both sides of the equation and know what we're going to be adding. So here is the process. We start with our general form, put the x's and y's together, because that's really what we see when we are looking at this particular standard form. So x squared minus 2x plus y squared minus 4y equals 4. And now to complete the square, what we do is we take half of this middle number, that coefficient, we square it, and then that's the number that needs to be added on. So if we go back and look at these, this 9, the way we can get there is 6 divided by 2 squared. This 25 is negative 10 divided by 2 squared. Same thing is true over here. This 4 would be negative 4 divided by 2 squared. 16 would be 8 divided by 2 squared. So that's the pattern that always seems to hold. So that's what we can figure out we're going to have to add. So this one, I take negative 2 divided by 2 and I square it. I take negative 4 divided by 2 and I square it. And when I add it onto this side, I need to keep it balanced with our equal sign. So I add it on to the right-hand side as well. And now that I have x squared minus 2x plus 1, I can factor that into this binomial squared, y squared minus 4y plus 4 into this binomial squared. And when I put these together, 4 and 1 and 4, I get a 9. And lucky for me, that's a perfect square. So I can also see that the radius is going to be 3, and the center would be at 1, 2. So let's try a couple. First one here. X squared plus y squared minus 6x minus 8y. So rearrange, put your x's together, put your y's together. And as you see in Ms. Lovell's work here, she already sets it up. What do I have to add here? What do I have to add here to complete the square? So negative 6 divided by 2 squared. So negative 3 squared. Negative 8 divided by 2 squared. So negative 4 squared. Notice she adds it here and she adds it over here. She adds negative 4 squared, and she adds it on the right side. So make sure that you're doing that, keeping your equation balanced. So as we simplify, we get x squared minus 6x plus 9, and y squared minus 8y plus 16. And as we add all these together, I get 36. Finish it off. I factor that, and I factor that. So that's x minus 3 squared plus y minus 8 squared. So my center's at 3, 4, and the radius is at 6. So again, there are the steps, making sure that we add things to both sides and we figure out what number needs to get added. Good strategy there. Put the blanks in. You can even put them over on this side so we understand I'm going to have blanks that I have to make sure that I fill in. All right, let's try another one. X squared plus y squared plus 4x minus 10y equals 20. So again, we're going to rearrange x squared plus 4x plus blank plus y squared minus 10y plus blank equals 20 plus blank plus blank. So 4 divided by 2 squared. So that's 2 squared, 4. Put that on both sides. Negative 10 divided by 2 squared would be 25. So add 25. Now I'm going to factor this part, and I'm going to factor that part. And I get x plus 2 squared plus y minus 5 squared, and we get our 49. So again, the completing the square, let's just rewrite this as a binomial squared. Lucky for us, we get a 49, so the square root of 49, that's easy to find the radius, which is going to be 7. Again, one more time here, a little bit less work area for us, but we can still do that. We're going to put together the x's. I need to add 1 squared. Put together the y's. I need to add 2 squared. So I've got a 31 originally plus a 1 plus a 4. So I get a 36 on the right-hand side, and this factors into this, and this factors into y plus 2 quantity squared. Got my center, 1 comma negative 2. Radius is going to be at 6. All right, so now we have some coefficients in front. So that's going to be a little bit different process. We have to make sure that we're careful on what we're adding. So main idea here, first thing that we did is we divided out or factored out the 9. So this becomes a 2x. This becomes a negative 2y. Put the 9 out in front. And then I have this trinomial. I take this number divided by, now this number is a 2. This number divided by 2 and square it. So I have a 1. So I have a 1 in there. Now what I'm actually adding, though, if you look on the other side of the equation, is a 9. So think about, why is that a 9? Well, this 9 is being multiplied times all of these things. So when I add a 1 inside the parentheses, I'm actually adding 9 times 1. So that's why I have to add a 9. And it's the same thing with the y's. This 9 is being multiplied times everything in there. So that negative 1 squared is 1. I'm adding 1, but I'm really, in reality, adding a 9. So we add 9 twice, once for each of those, the x and the y part. Simplify the right-hand side, and I get 4. Simplify the left-hand side, 9 times x plus 1 squared plus 9 times y minus 1 squared. Now, if we look back at our standard form, there's not a coefficient out in front there. So my next step would really be, we're going to divide everything by 9. So my answer would be x plus 1 squared plus y minus 1 squared equals 4/9. So my center, negative 1, positive 1 for the y, and then the square root of 4/9. So the square root of 4 is 2, the square root of 9 is 3, so the radius is going to be 2/3. So that's what I do if there's a number out in front, and we'll see that on the ellipse in a little bit. All right, now that we've seen that with a circle, we're going to try with an ellipse. So what's going to be different with these is we're going to have those coefficients out in front, and they're going to be different if it's an ellipse. So we start with our general form that we see here, and we want to get it to look like this for our standard form. So this is different. We want it to have a 1 over here, so we got to make sure we get that at the very end. Other than that, it's going to be pretty similar to what we just did with the circle. So the first step is, let's put our x's and y's together like we did before. And then we're going to factor out, just like we did with that 9, we're going to factor out that leading coefficient. It makes it an easier process for us to find out what we need to add to make that a perfect square trinomial in there. So we factor out the 4, we factor out the 25. Now complete the square. Again, take half of that middle number and square it. We have to make sure we add it onto both sides so we keep it balanced. And we have to be careful to make sure that we include whatever that multiplier is out in front. Think about distributing. So for this one, for the x's, -2 divided by 1 and then square it, I'm going to add 1 inside the trinomial. But I'm really not just adding 1, I'm adding 1 times 4. So we have to add a 4 to both sides. So there it is with the x's. Now let's look at the y. -6 divided by 2 would be 3. 3 squared would be a 9. So we're going to add 9. But it's really 25 times 9. So we have to add 225. All right, now I can factor this. X squared minus 2x plus 1 becomes x minus 1 squared. Still have the 4 out in front. Y squared minus 6y plus 9 factors to y minus 3 squared. Still have the 25 out in front. And when I combine all those things on the right-hand side, I get a 100. All right, so remember the goal is, in the end, I want to have a 1 over here. Well, I don't have a 1, I have a 100. So the way to make that a 1 is I'm going to divide by that number. So I divide by 100, and I divide everything by 100. Once I divide by 100, I can also then try to simplify. 4 goes into 125 times, 25 goes into 104 times, 100 divided by 100 is going to be the one that I was looking for. Again, some people think that that number always ends up over there. That number always ends up underneath the x minus whatever squared. That is not always the case. You have to pay attention to how these simplify. 4 over 100 is 1 over 25. 25 over 100 is 1 over 4. It's not some magic that it's just those other numbers. That will happen on occasion. Actually quite a bit with some of the examples we're going to see, but it's not always. Explain why we had to add 4 and 225 to the right-hand side when we completed the square instead of just adding 1 and 9, because there was the 4 in front and because there was the 25 in front. We factored those numbers out, so then we have to make sure that we are going to use those particular numbers when we are going to be multiplying. All right, so let's try some. 4x squared plus y squared minus x squared plus 4y equals 8. So put the x's and y's together. Factor out the GCFs. So this one, I'm going to factor out the 4. This one, there's only a 1, so I don't have to worry about it. Then I figure out what I have to do to complete the square. Again, you can see that Miss Lovell had the blanks in there, and we've got the blanks on that side. So she's going to add 1, but she's really adding 4 times 1. So that's why there's a 4. And then she added a 2 squared, so there's another 4 over there as well. Completing the square. This is now a perfect square trinomial. This is now a perfect square trinomial. So we can factor. And then I want this to be a 1 over here, so I'm going to divide everything by 16. And we notice 4 over 16 is the same as 1 over 4. This is just 1 over 16, and this ends up as a 1. So as we notice, that little pattern that maybe we thought was going to happen on the last one isn't actually going to happen here. The center now, we can tell, is going to be at 1, -2. The horizontal radius is going to be the square root of 4, so 2. The vertical radius is the square root of 16, so it's at 4. Try another one. 9x squared plus 4y squared plus 36x minus 24 equals -36. So put the x's together, put the y's together. This one now I'm going to factor out the 9. I'm going to factor out the 4. Figure out what I have to add. So the middle term divided by 2 squared is going to be a 4. So I add a 4, but it's 9 times 4. So we'll see 9 times 4 there, so a 36. And on the other part with the y's, -6 divided by 2 squared is -3 squared. So I'm going to add 9, but it's really 4 times 9. So there it is. It got a little bit cut off, but that's 4 times 9. Simplifying the right-hand side while I'm over here, -36 plus 36 plus 36. I get a 36. Factoring x plus 2 squared. Factor this one, y minus 3 squared. Again, that's why we picked those numbers. So we turned it into that binomial squared. And then I want to get a 36. I want that to be a 1. So I'm going to divide by 36 on all of the parts. 9 over 36 is 1 over 4. 4 over 36 is 1 over 9. 36 over 36 is 1. Now I can grab all of those important pieces. So the center's at negative 2, 3. Horizontal radius is the square root of 4, so it's 2. Vertical radius is the square root of 9, so it's 3. So I could easily make a sketch of that knowing those 3 pieces of information: center, horizontal radius, and vertical radius. All right, a couple more. 16x squared plus 4y squared plus 96x plus 8y equals negative 84. Put the x's together, put the y's together. 6 divided by 2 squared would be 3 squared, so it's a 9. But it's really, again, 16 times 9, so you'll see that over on the right-hand side. 2 divided by 1 squared, 2 divided by 2 squared, excuse me, is going to be 1 squared, but it's really 4 times 1. So there's my 4 times 1. All right, so x squared plus 6x plus 9, that's a perfect square trinomial. We factor that into x plus 3 squared. X squared plus 2y plus 1, perfect square trinomial. Get y plus 1 squared. Combine this on the right-hand side, we get 64. Divide everything by 64. And we simplify. 16 over 64 is 1 over 4. 4 over 64 is 1 over 16. 64 over 64 is 1. Grab the center. Negative 3, negative 1. Horizontal radius is 2. Vertical radius is 4. One more. There's the equation. Rewrite it so the x's are together. Pull out the 16. Pull out the 25. Again, the leading coefficient that was on the y squared, leading coefficient that was on the x squared. Take that middle term divided by 2 and square it. So that's going to be a 1, but it's 16 times 1. So we'll see a plus 16. 1 squared. So I end up with a 1 over here, but it's really 25 times 1. So we're going to add 25. 359 plus 16 plus 25, I get a 400. There's my perfect square trinomial for the x's. There's my perfect square trinomial for the y's. 16 times, now I can factor that. X, factor the y's. And now I want this to be a 1, so I'm going to divide by 400. Divide by 400, and divide by 400. Simplify. 16 over 400 is 1 over 25. 25 over 400 is 1 over 16. And there's my 1. So the center is at positive 1, negative 1. Horizontal radius is 5. Vertical radius is 4. So there's our switching among forms activity. So we should hopefully be able to go between general form and standard form.